you for the introduction. So I'll go ahead and dive right in. I'm going to try to make my way through and we want to cover here today in the prescribed amount of time. So today, to start with, I'm just going to briefly define what intermittent fasting is. There is definitely some disagreement on this, even amongst researchers in this area. So I think it's important we sort of have our terms established before we dive into some actual studies. I normally would like to talk about intermittent fasting in the general population before diving into exercising individuals, but with a 30-minute slot, we won't have time. So I cut out all the general population and we're just going to talk about those who exercise, and then we'll go through some applications and conclusions at the end. So here to start with, in terms of what intermittent fasting is, I'm going to talk about a few broad features because this is a very broad term. I often see people ascribe very narrow, specific definitions to the term intermittent fasting, but this is a broad term. Then we'll go through the major forms of intermittent fasting as I see them, as I categorize them, and then briefly summarize. So broad features of these eating programs. First, big picture, these patterns focus on when you eat, not necessarily what you eat. And as a minor side note, I think this is one of the reasons intermittent fasting is relatively popular, because many people don't like to be told what to eat, and they like being able to continue to eat what they want to eat. And it might be a little easier to change when they're eating rather than what they're eating. Intermittent fasting is related to the concept of intermittent energy restriction. So there are other forms of intermittent energy restriction that we won't get into today, but I just want to acknowledge that these are related concepts. Generally, these programs include regularly occurring fasts that are longer than a normal overnight period. And of course, normal varies widely based on the person. There are some data here from the United States saying that the median fasting time might only be around 9 hours. So many individuals in our country eat from the time they wake up until the time they go to bed. This isn't always the case, but lots of these programs will often reduce eating frequency, either on a daily basis or a weekly basis. So some of these programs would involve no reduction in eating frequency on a number of days per week, but then there might be 1 or 2 days where eating frequency is reduced. Many of you, I know Joey being one of them, is probably wondering, like, what is the purpose of this, not eating? Many believe they're the reason many people follow these programs. One, simply to decrease energy intake, to decrease body mass or body fat. Some of the emerging research and what lots of people are interested are some of these health aspects, if you can improve health through intermittent fasting. In this note on here, I say sometimes there may be no purpose. And all I really mean by that is that many people may follow what looks like one of these programs unintentionally. So if you have someone that skips breakfast, they eat lunch, and they don't eat late into the night, they might be following an eating pattern that would look similar to 8-hour time-restricted eating, which we'll talk about. But they may not be doing that intentionally. It's just how they eat. So intermittent fasting is proposed to enhance cell function and stress resistance. This is somewhat up for debate. This figure is from an interesting article in the New England Journal of Medicine that generated a decent amount of controversy, but it brings up some interesting points about not only intermittent fasting, but calorie restriction and some of the pathways through which it may act. These programs are proposed to exert weight loss dependent as well as weight loss independent effects. And then in some cases, and for some particular forms, these programs are supposed to improve alignment of nutrient intake with our inherent circadian rhythms. So this would have implications for things like when we might most optimally process or metabolize a given meal. So those are a few broad features. Now I'd like to briefly cover the major forms of intermittent fasting. And these may be some of the specific terms that you've heard. So to start out with alternate day fasting, and I'll have a little graph like this for each form. Here, this is just showing the percent of energy intake on each day. So the original alternate day fasting is just like it sounds. You essentially eat every other day, which is a pretty rigorous program. So this essentially involves regularly occurring 36-hour fasts, which are fairly challenging. But for these programs, and there have been several research studies on these, you would have normal or unrestricted eating on one day, followed by no calorie intake on the next day. And you continue that every other day pattern indefinitely. So that understandably was fairly challenging. So the research, early research that showed a little bit of lean mass loss with alternate day fasting proposed that adding a small amount of calorie intake to these so-called fasting days may be protective of lean mass. So most of the studies since that time have actually used modified alternate day fasting. So this is just like alternate day fasting, except a small amount of calorie intake is actually allowed on the fasting days. Uh, and this does mean that this is not actually fasting, this is modified fasting. Depending on when you place that calorie intake, though, on the so-called fasting days, you may still have some relatively long fasting periods. So it's most common for this to be a small lunch. So you'd essentially fast overnight until lunch the next day, eat a small lunch, and then you'd be fasting again till breakfast the next morning. This is still a relatively challenging form of intermittent fasting. The next subtype is called periodic fasting, and this is probably the broadest subtype. So there are a number of specific programs that could be lumped into this term. But generally, these programs consist of fasting periods. They're implemented as infrequently as once every few months to as frequently as twice per week. Lots of times these forms, implementations of intermittent fasting involve a little bit longer individual fasts. So these are often fasts that are 24 hours or longer in length. Many of these 24-hour fasts don't actually involve a calendar day without eating. So some of these programs, Eat, Stop, Eat being one example, and I showed a schematic here, showing Eat, Stop, Eat. Well, this is a little bit different than Eat, Stop, Eat on the schematic, but Eat, Stop, Eat would be a couple 24-hour fasts each week, but that would be essentially from dinner one day till dinner the next day. So you don't necessarily have a calendar day in which you're not eating. However, other implementations of periodic fasting might be something like a 2-day fast every several weeks. So somewhat of a broad subtype, periodic fasting. Similar to alternate day fasting, there is modified periodic fasting, where instead of having, say, a day with no calorie intake or a prolonged period of time with no calorie intake, it's just a large reduction in energy intake. So a common example here is the 5-2 diet, and you can see that in the schematic. There'd essentially be 2 very low calorie intake days per week, either placed consecutively or non-consecutively, and then the other days consist of normal eating. So again, these modified fasting protocols really aren't fasting per se. They involve fasting periods, but they're often just very low calorie intake days interspersed with unrestricted days. So the form that is probably most popular and that many people think of when they hear the term intermittent fasting is time-restricted eating, also known as time-restricted feeding. Here, the graphs I'm showing are a little bit different. This is just showing the number of hours in a day and the hours that are fasting hours versus feeding or eating hours. So generally, these programs just refer to eating all your calories within a certain number of hours each day. And again, this is often what people think of with intermittent fasting. These are some of the more popular implementations. Most commonly, all food is consumed within a 4 to 12 hour period of time each day. However, the consumption period could be as low as 1 hour in a kind of extreme variant of time-restricted eating called OMAD, or 1 meal a day. You would have essentially a 1 hour period of time each day in which you eat all your calories. So then the remaining 12 to 20 plus, say up to 23 hours a day, there are no calories ingested. So here the little graphic updated just to show what 24 time-restricted eating would be. So 20-hour daily fast. Just one note before we move on. It is typical for most forms of intermittent fasting to spontaneously reduce energy intake. We can't go into those data today just for the sake of time, but they're quite a large bit of data in the general population showing this generally occurs, though it does depend where the person starts. Again, some people might already be following a eating pattern that resembles some variants of intermittent fasting. But you could also have something here, if you're looking at time-restricted eating, you could have someone consuming all their calories within a truncated period of time each day, but they're still hitting 100% of their energy needs, say their weight maintenance energy needs. So really any of these forms could be employed without energy restriction. It wouldn't be very easy for some of the forms, but time-restricted eating is a good example where someone might be getting all their weight maintenance calories within that period of time. However, again, for many people, you do have somewhat of a spontaneous reduction in energy intake. So that'd be showed here, say if someone had a 20% reduction in energy intake by truncating their feeding window. Okay, so those are the three major forms. So just to summarize before we dive into some of the research in athletes. So intermittent fasting is a broad term. It includes multiple eating patterns. Generally, those eating patterns focus on when you eat rather than what you eat. They involve intermittent periods of energy restriction, often complete fasting, though there are some of those modified fasting protocols. And then there are regularly occurring fasts that are longer than a normal overnight period. Again, major forms: alternate day fasting, periodic fasting, and time restricted eating. I have a little note here. We won't get into it much today, but different implementations of religious fasting can certainly overlap with these forms. And then again, you can have true or modified fasting in these programs. And true fasting is what we think of actually as fasting. Modified fasting is just very low energy intake. Okay, so that's just a quick look at what intermittent fasting is. So now I'd like to dive into some of the studies on intermittent fasting and exercise. First, we'll talk about just a couple studies that have very recently been published looking at individuals performing endurance training. We'll talk about some studies in resistance training, including 4 that have been done by our group, and then we'll summarize. So I'll start off by saying that intermittent fasting is polarizing in active populations. There are many people who think it's absolutely the worst thing you could ever do. There are other people that think it will improve everything: body composition, health, even performance. And the truth, of course, is probably somewhere in the middle and is obviously context dependent. So there are, as background, several studies that have shown impairment of high intensity performance following acute periods of fasting. Some limited data show that performance may return to normal as these fasting periods are regularly implemented for 4 to 10 days or longer. But before we even go into the specific studies, I'll mention that no human studies have shown an inherent performance benefit. And that may seem obvious, but some of the claims you see related to intermittent fasting may lead you to believe otherwise. There are only a couple non-Ramadan intermittent fasting studies with endurance training. And just as a brief summary, Ramadan intermittent fasting literature is very interesting. There are a number of studies in athletes and active individuals. However, there are a lot of confounding factors with this body of research. Virtually all of the studies are 4 weeks long. They're largely observational, so they just observe what's happening to athletes, observant athletes as they go through the Ramadan period. Depending on the geographical location and time of year Ramadan falls on in a particular year, you could have very different durations of daily fasts. Strict observance to Ramadan also involves not consuming fluids during daylight hours. So there are a number of confounding factors. So for that reason, we won't discuss the Ramadan intermittent fasting literature today. However, thankfully, there are 2 very recent time-restricted eating studies in endurance athletes. So one of those is in runners, and the other was in cyclists. So I'll briefly summarize those here. So just a few months ago, Brady and colleagues in MSSE published a randomized controlled trial that was 8 weeks long in 17 middle and long distance runners. So this protocol used so-called 8-hour time-restricted eating, or 16-8 time-restricted eating. You can see that represented there in the figure. And they randomized participants to either the time-restricted eating group or the control diet, which essentially just continued the normal diet with an eating window of about 13 hours per day. A major limitation of this study was that the training routine was unsupervised. They did a decent job of load monitoring, but still unsupervised training. And they performed pre and post assessments of dietary intake, body composition, and running performance. So the major results, based, again, limitation of it being self-reported, but they saw no differences in training load. Time-restricted eating did reduce energy intake. So without any other dietary instructions, reduce energy intake and body mass by about 2 kilograms on average. If you look in the bottom right portion of the screen, and hopefully you can see my cursor here, there was essentially one individual in the time-restricted eating group who finished the 8 weeks at a higher body mass than they started. Whereas there was only one individual in the control group who finished the 8 weeks at a lower body mass. The individual changes in body composition compartments weren't significant. These changes were estimated by bioimpedance and not the best form of bioimpedance, so those have to be taken with a grain of salt. But it is a little bit interesting that just based on the mean values, they were showing a larger loss, about 2-fold larger loss of fat-free mass as compared to fat mass. And then there were no effects on oxygen consumption, substrate utilization, running economy, or any other markers they looked at. So they ultimately concluded that 8 weeks of this form of time-restricted eating decreased body mass due to the decrease in energy intake, but didn't alter endurance running performance or metabolic health. So the other study in endurance athletes was just very recently published in the Journal of the International Society of Sports Nutrition. I was able to be involved in this study as a co-author. The data collection took place in my collaborator Antonio Paoli's laboratory in Italy. This was only a 4-week trial, but I think the unique aspect of this was that these were true athletes that were being studied. So there were 16 elite under 23 cyclists from 5 different cycling teams. Here they were randomized to be part of a time-restricted eating group with an 8-hour eating window, or a control group with an eating window of about 12 hours per day. They were prescribed 4,800 calorie a day diets, obviously a higher calorie intake than we see in some of the studies of just general exercising individuals. But again, these were competitive cyclists. You can see their training there, 6 weekly sessions, 500 kilometers on average per week. And all training did take place within the eating window. In this study, we had pre and post assessments of body composition, again, by BIA due to kind of studying the multiple different cycling teams. That was just kind of a practical constraint, metabolism and exercise performance. So major results, TRE did reduce body mass by about 2% on average. There was no effect on most performance metrics. The sole item that could be construed as a performance benefit was the fact that the peak power output to body mass ratio increased, but this wasn't due to an increase in absolute power output. Essentially, the cyclists in the time-restricted eating group were able to maintain their power output while decreasing body mass, which is what caused this ratio to increase. So ultimately, our conclusions here were that this 8-hour time-restricted eating program elicits weight loss and increased peak power output relative to body mass, again, due to the reduction in body mass, and that it could be considered as a component of a periodized nutrition program. So again, just two recent studies here, but based on a very limited amount of data, the time-restricted eating with the 8-hour eating period may reduce ad lib energy intake in endurance exercisers. It may reduce body mass, but it does not clearly affect absolute metrics of exercise performance in the short term. Clearly, more data and longer term data are needed here on the endurance athlete side. There's just one other item I want to mention here in endurance training before we move on to resistance training. The Brady study in runners did not control when participants exercised in the fasted or fed state, and they didn't report those data either. I'm not sure if they even collected them. So neither of these studies necessarily involved fasted training, but a question that sometimes comes up related to intermittent fasting, particularly with some of these endurance exercise sessions, is the idea of fasted training. So I just want to briefly mention a great meta-analysis performed in 2018 that included 46 studies that had examined fasted training. So this meta-analysis concluded that fasted training does decrease prolonged aerobic performance, which shouldn't be a huge surprise based on our knowledge of sports nutrition, best practices and guidelines. The effects on short duration performance were equivocal. In terms of metabolic characteristics, there is an increase in free fatty acids and signaling related to mitochondrial adaptations with fasted training, but again, at the expense of prolonged performance. So these authors present a nice balanced view of things. They essentially say that fasted and fed training divergently influence exercise metabolism and performance. So we know pre-exercise feeding bolsters prolonged performance, but they presented some of this compiled evidence that there might be beneficial metabolic adaptations to fasted exercise in terms of especially mitochondrial adaptations in the peripheral tissues. So I don't think anyone, well, hopefully no one would advocate when you need peak performance for performing fasted, but these authors and others have put forth the idea of fasted training as a periodic train low strategy that would be part of periodized nutrition. So as you all, likely will be familiar, train low often refers to lower carbohydrate availability, potentially energy availability, with the idea that this increases metabolic stress and signaling for adaptations. Not that you get peak performance by this, but that you could elicit adaptations that may be beneficial in the long term. So just wanted to briefly mention that. So just a little bit of information on endurance training. In terms of resistance training, there was a recent systematic review by Keenan and colleagues in 2020 that located 8 studies of intermittent fasting plus resistance training. So 4 of those were time-restricted eating studies, and all 4 of those are from our team. There were 3 Ramadan studies, which, as mentioned, we won't go into today. And there was one alternate day fasting that had some limitations that would make it less applicable to the crowd here today. So in terms of the research from our team, I've been fortunate to be involved with a few different universities here. So one of these studies was, again, conducted in Italy in Antonio Paoli's lab. I led another one at Baylor University as a doctoral student there. I led one here at my lab at Texas Tech University. And then the fourth one listed here was conducted in Trisha Van Dusseldorp's lab at Kennesaw State University by one of her master's students, who is now one of my current PhD students. So I'm going to briefly discuss just two of these because we don't have time to discuss all four, the one conducted in Italy and the one conducted here at Texas Tech. So the first one, this one has generated a decent amount of attention over the last 5 years now, I guess. This was a randomized clinical trial, 8 weeks long, in 34 resistance-trained males. These were highly trained males, so I think their average BMI was over 28 with a DEXA body fat percentage of 13% on average. So overweight by BMI, low body fat percentage tells you that they're relatively muscular individuals. Many of these identified as natural bodybuilders. So they were randomized into either a time-restricted eating group that consumed 3 meals at 1, 4, and 8 p.m. each day, resulting in an eating period of about 8 hours each day, or a control diet that consumed 3 similar meals but spaced out further to have a 13-hour feeding window each day. Both groups completed 3 days a week of supervised resistance training in the non-fasted state, and also took protein supplements post-exercise. So major results, there were no changes in lean mass assessed by DEXA over the 8 weeks, which isn't surprising, I would say, in this training status. There was fat loss with time-restricted eating, but not control. The absolute amount wasn't huge. I mean, it was good for how lean they were, 1.5 kilograms. But if you look at this chart, the fat mass loss will look larger just because they were lean to begin with. So in terms of the absolute loss, it was about 1.5 kilograms on average. Some of the interesting results were related to reduced inflammation and improved blood lipids with time-restricted eating. But in terms of performance, the groups were very similar, so similar maintenance or improvements in select markers. So we ultimately concluded that in certain contexts, this could be beneficial if you're looking to improve health markers, reduce fat mass, and maintain muscle mass. Again, we weren't promoting this as a one-size-fits-all, but we were saying this could be used during selective maintenance phases of training. So you may have noticed every study I've discussed so far has been in males, the 2 in endurance athletes, the one I just mentioned. So one of the unique aspects of the one we conducted here at Texas Tech was that this was in resistance-trained females. So it had a relatively similar protocol to the one I just mentioned with the 16-8 time-restricted eating, but again, in resistance-trained females. In this study, we had 3 groups. So 2 of them were time-restricted eating groups. 1 consumed additional HMB supplements during the fasting period. And then the control diet was required to eat breakfast every morning, and that ultimately resulted in them having an eating window of about 13 hours each day. All groups completed 3 days a week of supervised resistance training and also consumed protein supplements daily to get their average intake up to about 1.6 grams per kilogram of body weight per day. So you can see here with my cursor, we saw similar increases in whole body fat-free mass. This was assessed by a 4-compartment model. We saw similar increases in muscle thickness of the elbow flexors and the extensors. So really no differences between groups, no compromising of adaptations when overall protein intake and calories were similar. There was, if you look here for body mass, there was no change at all in either of the time-restricted eating groups on average. There were reductions in fat mass that were significant at certain time points, either 4 weeks or 8 weeks, depending on the group. And then in terms of performance, we saw very similar improvements in all groups over time. So we looked at 1 repetition maximum on the bench press and leg press, repetitions to failure. We looked at peak eccentric, concentric, and isometric force production on this mechanical squat device, as well as rate of force production, vertical jump, a variety of other metrics. We essentially saw time-made effects for improvements in all groups without a difference between groups. So from this study, we concluded that similar gains in fat-free mass, skeletal muscle hypertrophy, and muscular performance can be achieved with dramatically different feeding schedules, provided that the energy and protein intake are similar during a progressive resistance training program. So based on the studies from our team, the two I briefly mentioned, as well as the ones that I didn't have time to cover, we can conclude time-restricted eating is a viable strategy for body composition improvement when it's paired with resistance training and sufficient protein intake. In the short term, we can conclude it doesn't compromise exercise adaptations. However, some caveats. These resistance training studies weren't in true athletes. Of course, if you have someone who's resistance training as part of an overall program to improve sports performance, you should probably inherently be skeptical of intermittent fasting for reasons like missed eating opportunities. In all these studies, if they are free living studies, we ultimately have insufficient dietary control to establish a benefit of time restricted eating beyond just reducing energy intake. So even though we have several studies showing no difference in self-reported dietary intake, even with weighed food records. So in the study in females, we provided with all participants with food scales, weighed their food, tried to exert the highest level of control we could in a free living setting. But ultimately, if this is outside of a metabolic ward, we can't establish definitively that there are any unique benefits beyond reducing energy intake. And then, of course, these are not long-term data. So these go up to about 8 weeks. So it doesn't tell us if these programs were continued for months or years, how long-term adaptations would be influenced. Okay, so to briefly summarize here, in active populations, as you noticed, most studies have been on time-restricted eating with an 8-hour eating window. This doesn't clearly affect endurance exercise performance, but may reduce energy intake and, because of that, body mass. When combined with resistance training, time-restricted eating, at least with down to an 8-hour window, is a viable strategy for body composition improvement. If you're dealing with true athletes, of course, the risks and benefits should be considered. Theoretically, this could be part of a periodic train low strategy. You, of course, want to consider sports nutrition best practices for optimal performance and not do anything to compromise performance if you're dealing with true athletes. If used at all in these populations, intermittent fasting should be used strategically and I would say cautiously. And ultimately, the risk, even just a risk of impaired performance, may outweigh any potential body composition benefits for most athletes. So just briefly, in the last couple minutes I have, I want to go over just some rapid applications and conclusions. So first, we'll start with the bad. I know there'll be some people happy to see this. Who is intermittent fasting bad for? So first, those who don't enjoy this pattern of eating. If you're like the individuals in this cartoon who have withdrawal symptoms after not eating for 5 minutes, this may not be for you. If you feel that intermittent fasting styles of eating initiate or exacerbate disordered eating, including binging, they may not be appropriate. If there's a medical condition that could be adversely affected, certainly not appropriate. If you simply don't want to, none of the data so far have been compelling to the point where we need to get people who don't want to fast to fast. If you do try this and you don't experience the desired results, this may not be best for you. If you believe intermittent fasting could impair your performance in relevant tasks, notably exercise performance, this may not be for you. Conversely, some people who might benefit from intermittent fasting, some people legitimately enjoy this pattern of eating. They would rather not eat for a long time and then eat some large satisfying meals rather than eating small meals, say throughout the day. Many individuals, I think, are drawn to these programs because they just want a simple way to create a calorie deficit without necessarily counting calories. And there's certainly other ways to do this besides intermittent fasting, but some with time restricted eating, for example, I think enjoy the simplicity of saying like, okay, I eat during this period of time and I know for me, this will get me to the calorie deficit I want for a day. If you do not tend to overcompensate, and there's a lot of individual variability here, we weren't able to get into those data today, but if you don't tend to overcompensate after fasting periods, that may be a good sign. Of course, rubber meets the road. If you try one of these programs and you're happy with the results you're experiencing, this may be good for you. If you don't experience performance decrements relative to what you care about in terms of performance, that could be a good sign. And then when considering intermittent fasting, a trial period, I would say is recommended based on a limited amount of data and based on participant interviews. It often takes about 2 weeks before someone is somewhat acclimated to this eating pattern. And we've had really mixed results in our studies. By the end, we have a number of participants who say, this is the eating pattern for me. I want to continue this indefinitely. And we have other individuals saying, I'm never going to do this again. I want to eat every 2 hours throughout all my waking hours for the rest of my life. Okay, so I think I see 30 seconds here. So conclusions. Intermittent fasting is a broad concept including multiple eating patterns. There are numerous ways to implement intermittent fasting. For many, this is a simple way to limit energy intake and promote a calorie deficit. However, this is not magical or even necessary. The choice of whether or not to use any of these programs should be highly individualized. So some see good results, enjoy this. Others do not see good results and do not enjoy this. In exercising adults, consider how fasting periods relate to your training sessions and overall goals. Is this a good tool for you to reduce energy intake? Do you want to implement this as a train low strategy? Or is this just something that compromises your optimal fueling for performance? Of course, for true athletes, performance has to come first. And again, I recommend skepticism towards intermittent fasting in this context. And if implemented at all, it should be implemented very conservatively and strategically. With all that said, if you're more in the recreationally active or just training for body composition improvement, this may be a simple strategy to consider. So with that, we've covered what intermittent fasting is, a few studies on intermittent fasting and exercise, and then some brief applications and conclusions. So I'd just like to thank you for listening. And there's some information here where you can get content about our lab. And I do try to post about our studies and other things going on social media as well. So thank you for listening.
Thank you, Dr. Grant Tinsley. Hey, just one quick question, and before you